Upsc-Ese YouTube channel. Today we are going to learn about most efficient trapezoidal section in the topic of uniform. So let us start this video. So today's topic is most efficient trapezoidal section. Okay, so there are two cases with the trapezoidal section. One, when side slope is fixed. Okay, so how to deal with this case? So let us first draw this diagram. So this will be our trapezoidal section. In this case, since we are fixing the side slope, so let us take the slope as m is to 1. Okay, here base width will be capital B and depth of flow, let us take y. Okay, so for one depth there is m width. Okay, so for y depth there will be my width. So we can easily find the top width of this channel section. This will be my and this will be also my. So the total top width will be how much? The top flow width will be top flow width is equal to T is equal to B plus my plus my. So this will become T is equal to B plus 2my. Okay, and if we are supposed to find the area of this cross sectional flow, so area in the case of trapezoidal section is given by half into this will be sum of the parallel side, that is B plus another B plus 2my, the top width, and multiply the distance between them, which is y. So if you will solve this or simplify this, you will get area is equal to B plus my into my. Okay, so here we have three variables, m, y and b. Okay, so we have to reduce it to one variable. So how we can reduce? Let us see. So since we have found out the area, let us find out the perimeter or wetted perimeter of this channel section. So wetted perimeter will be P is equal to B plus 2y under root m square plus 1. So how we got this? See, we have to find the wetted perimeter. So this will be something like this. See, this width is B, and using Pythagoras theorem we can find the side width also. Since this is my and this is y, so this will be y square plus my whole square, or we can say this is equal to y into 1 plus m square. So if you take the twice of this, it will give you the side slope width. Okay, so b plus 2 times of y under root m square plus 1. Okay, now from area equation we know a is equal to b plus my into y. From here we can write a upon y is equal to b plus my, or we can write b is equal to a by y minus my. Now if we put value of b, this value of b in perimeter equation, the perimeter equation will change to one variable, that is y, and there will be only one constant, that is two constant m and a. Okay, so it is very easy to differentiate them, because since in the case of most efficient channel section we have to minimize the perimeter so that the cost gets reduced. So let's do that. So if we put that value, we were getting p is equal to a upon y minus my plus 2y under root m square plus 1. Okay, now let us differentiate. We have to keep in mind that here a and m are fixed. The only variable thing is y. So while differentiating you have to keep this in mind. Okay, so why we are differentiating it? We have to find p minimum. For p minimum, what we have to do, dp upon dy, we have to put 0. Okay, so let's do that. So this will give you minus a upon y square minus m plus 2 under root m square plus 1 is equal to 0. Okay, now we can write a by y square plus m is equal to 2 under root m square plus 1. Okay, now if we multiply y on both sides, we can get a upon y plus my is equal to 2y under root m square plus 1. See, in the place of a upon y, we can write b plus my. Okay, so let us write b plus my plus my is equal to 2y under root m square plus 1. What is the reason behind this? So reason behind this is that since area is equal to b plus my into y. Okay, so this becomes b plus 2my is equal to 2y under root m square plus 1. Now if you observe carefully, b plus 2my is nothing but the top width. Okay, b plus 2my is nothing but the top width of the channel section. So we can write E is equal to 2y under root m square plus 1. So this is one criteria for the efficient trapezoidal section. Okay, or we can also reduce it to like this. If you take 2 on the LHS, it will become t by 2 is equal to y under root m square plus 1, and we know that y upon y under root m square plus 1 is nothing but length of the side slope. Okay, so this gives t by 2 is equal to length of side slopes. So in the case of most efficient trapezoidal section, we can say the half of the top width is equal to the length of the side slope. See, this is the first condition, okay, for the efficient trapezoidal section. So we can say this is the first condition. Okay, now let us find the hydraulic radius for this condition. So hydraulic radius is given by hydraulic radius is given by R is equal to A by P, that is cross sectional area divided by perimeter, wetted perimeter. Now put all the values. Area is given earlier, B plus my into y divided by wetted perimeter is B plus 2 times of y under root m square plus 1. Okay, now we have already proved that 2 times of y under root m square plus 1 is equal to top width. So we can write R is equal to B plus my into y divided by B plus top width. And what was the top width? Top width was B plus 2my. So let us put that B plus my into y divided by B plus 2my. So if you simplify this, you will get B plus my into y, or 2 times of B plus my, or this will give you R is equal to y by 2. Okay, so this is your second condition for efficient trapezoidal section. Okay, so if we draw all this geometrically, what you are going to get? Let us draw it. See, this is the depth of flow y, this is base width b, the slope here it is 1 vertical is equal to m horizontal, and if we extend this is y, then this will be my, this is my. Okay, then this will be half of top width t by 2. Okay, now we are going to derive one condition here. If we take an circular arc. The center is as the center of the top width. If we take this as x and this is x, this is 90 degree, this is 90 degree. If you take this angle as theta and this is r, this c, this is a d, this is o, this is y. Then we can see what we are going to get. See, if we use this diagram and try to look at in triangle AOP, okay, in triangle AOP, if we see sine theta, so in triangle AOP this is theta, then this will be theta, and sine theta will become perpendicular divided by hypotenuse. So hypotenuse here is t by 2, and if we take triangle ACR, then sine theta is equal to y divided by y under root 1 plus m square, side slope length. Since from both equation you can write that sine theta should be equal to sine theta, so this gives x divided by t by 2 should be equal to y divided by y under root 1 plus m square. Now if you remember, in the first condition we have derived that t by 2 is equal to y under root 1 plus m square, so this gives us x is equal to y. So you have to put this as third condition, and here you can write also t by 2 is equal to y under root 1 plus m square, okay. So for efficient trapezoidal section, a circle of radius y shall be inscribed in the trapezoidal section, okay. So all these three conditions should be satisfied. So let me summarize this for you. The first condition was t by 2 is equal to y under root 1 plus m square. The second condition was r should be equal to y by 2, and the third condition of x should be equal to y. Inscribing a circle should be there, okay. So regarding the case 2, that when side slope is varied, we will see that in our next video. If you have liked this video, please subscribe to my channel, comment it and share it with your friends. Thank you for watching. Have a nice day.